Welcome guys, you are welcome to our class for today. Today we're going to be looking at rectilinear motion stroke acceleration. So this is Number Minds Tutors Online and I remain Otubo Michael. Please, if you have not subscribed to our channel, I encourage you to subscribe by clicking on the subscribe button and also click on the notification bell so that whenever we upload a new video, YouTube will notify you. This is actually a physics class from your normal classroom, and we are bringing physics lecture or physics learning right to your very doorstep. So please, if you like what we're doing, give us a thumbs up, and you can also give us a like, comment on the comment section so that we will know how you feel about our videos. Then also you can reach us through the WhatsApp line that is showing on your screen. Alright, so for today we are going to be looking at rectilinear motion stroke acceleration. So as I've always said, please get your writing materials and then be settled so that you will not be distracted. So right here we will be looking at rectilinear motion stroke acceleration. Rectilinear motion stroke acceleration. So what is rectilinear motion? Rectilinear motion, simply put, is motion on a straight line. Rectilinear motion is defined as motion or acceleration in a straight line path. Okay, so when an object is accelerating on a straight line, we say that that object is undergoing rectilinear motion. Rectilinear motion. Now, when the velocity of a body or of an object that is in motion changes, it can either increase or decrease. So when it increases, we say the body is accelerating. When the velocity decreases, we say the body is decelerating. So an object that is in motion can either have a velocity that is increasing, which is acceleration, or a velocity that is decreasing, maybe due to brake that is applied, which is a deceleration. Then acceleration is defined as the increasing rate of change in velocity with time. That is just what I just explained now. Why deceleration is the decreasing rate of change in velocity with time. Deceleration, I want you to take note of this, that is also called retardation or negative acceleration, as the case may be. So in some textbooks, you can either read it as retardation or negative acceleration, as the case may be. Now with this, we can actually find that if an object has an initial velocity u, if an object has an initial velocity, okay, so if your object has an initial velocity u, is equals to u, and then you have a final velocity that is equals to v, then you can see that acceleration is changing velocity. Acceleration a is equals to changing velocity, which is final velocity, minus initial velocity u. Okay, all over the time taken, because acceleration is given as change in velocity all over time taken. So simply you can write this as v minus u all over t. Okay, so this gives you your acceleration. Now from this equation, from this simple formula, you can actually deduce the first equation of motion. You can deduce the first equation of motion, and that is exactly what that's what we're going to do in a moment, right? So acceleration or deceleration is given as change in velocity all over time taken for the change, or final velocity minus initial velocity all over time taken, and it's measured in meter per second squares. So with this formula in mind, or with these simple equations in mind, we are going to start to derive the equations of motion, and we're going to be starting with the first equation of motion. Okay, so equations of motion, and we're looking at first equation of motion. So for us to derive this, we're going to consider a body that is initially at rest or already in motion with an initial velocity u meter per second and accelerating at a meter per second square. After a time t second, the body will have attained a final velocity v in meters per second. So all this information that we have here, how can we put them into an equation, into a mathematical equation? So putting them together, we be able to derive the first equation of motion. So that is what we want to do now. Okay, so for this particular first equation, we will be given that initial velocity is equals to u. Initial velocity is equals to u. Initial velocity is given to us to be equals to u, and then have our final velocity to be is given to us to be v, and acceleration is equals to a, and then time t is t seconds. Okay, so these are the information that are in this particular statement. So how do we relate all these informations and put them into an equation, right? Okay, so we know that acceleration a is given to be what? Change in velocity, which is v minus u all over t. That is final velocity minus initial velocity, all over the time taken gives you the acceleration. So with this in mind, you can do cross multiplication. If you cross multiply this, you are going to have at equals to v minus u. You have it is equals to v minus u. Now you can do rearrangements to make v the subject of this formula. So if you do the rearrangement, you will have that v will be equals to u plus at, So this equation is your first equation of motion. This is the first equation of motion, right? So it's as simple as that. This is how to derive the first equation of motion from acceleration, which is change in velocity all over time, and then you do your cross multiplication and make v the subject of the formula, and you get your first equation of motion. That okay? I hope this one is simple, and then okay. So this is what I've done already. I'm just bringing them up. Okay, so this is what I did now, and then you have your first equation of motion. This is the first equation of motion. So by the time you do this rearrangement, you have your first equation of motion. Is that okay? So I hope this is simple, because sometimes students find it difficult to derive the equations of motion, and if you don't understand this process, sometimes applying this equation in solving problems becomes difficult, because there are three equations of motion. So if you understand their derivation, you will know what is given to you, and then you also know which of the three equations to apply in a particular question that has to do with motion. So it is always good that for a good physics student, you should be able to derive the three equations of motion. So we've done for the first equation of motion now, and then in our next class, in our next video, we will be looking at the derivation of the second and the third equations of motion. So this is where we're going to stop for this particular video. So guys, if you have not subscribed to our channel, please, I encourage you to subscribe to our channel. Click on the notification button, put your comment down below. You can also reach us on this WhatsApp number that is here. Place any question that you have on physics, we'll discuss it with you, and then see how we can help you out in areas where you have challenges with calculations in physics, because it is the calculations that are always majorly the problems of students. So we are ready to help you so that we become your best regarding physics. So thank you so much. We hope to see you in our next class.